This is the first video for section 2.5, the chain rule. So recall what we talked about with regards to function composition. When we write the notation f little circle g, which we say f of g of x, that means we want to take the function f and evaluate it at g of x. This is function composition. So for example, if I have the function f of x equals sine x and g of x equals the square root of x, then f of g of x is sine of the square root of x, and g of f of x is the square root of the sine of x. So in general, notice that order matters with regards to function composition. F of g of x is not in general equal to g of f of x. So the chain rule gives us a way to differentiate function composition. A lot of functions that you might actually see in the real world are comprised of sort of building block functions composed together. So the chain rule is one of our most important, or maybe the most important differentiation rule that we've gotten so far. So if I have two differentiable functions, f and g, both differentiable at x, and f is differentiable at g of x, then the derivative with respect to x of f of g of x is f prime evaluated at g of x times g prime of x. That's the chain rule. And there's another way to write the chain rule, which is we could let u equal g of x and then y equals f of u. So notice that if we filled in g of x for u, we would have y equals f of g of x. So this is just using a substitution for g of x. So f of g of x is f of u. Then we could write the chain rule as dy dx equals dy du times du dx. So that's saying f prime of u, which is f prime of g of x, times du dx, which is g prime of x. So this is exactly the same as our other chain rule, but notice here the folks that made up mathematical symbols were really smart. The derivative notation, it is not a fraction, but it kind of looks like a fraction, right? And so on the left-hand side, we have dy dx. On the right-hand side, we have dy du times du dx. It kind of looks like you can cancel those du's and be left with a dy dx. You can't actually do that, but it looks like it. And notice that can help you. It's kind of a good mnemonic to help you remember the chain rule. And so here's another way to remember the main version of the chain rule, or the first version that I wrote. So d dx of f of g of x is f prime of g of x times g prime of x. So if f is the outside function and g is the inside function, then the derivative of f of g of x is the derivative of the outside evaluated at the inside times the derivative of the inside. So, question for you, what is the derivative of f of g of h of x? What if I have three functions, or maybe even more functions composed together? And let's assume the hypotheses hold so that we actually can differentiate this function. Well, we're going to start from the outside and do the chain rule and just sort of think of it as an onion, peeling away layers until we reach the inside. So it's f prime evaluated at g of h of x times g prime evaluated at h of x times h prime of x. And we'll get some practice with increasingly complicated compositions of functions.